late autumn 1920, somewhere in rural Pennsylvania. A group of US Army officers stood in a muddy field watching soldiers struggle with equipment that seemed increasingly inadequate for modern warfare. The Great War had ended 2 years earlier, but its lessons burned fresh in the minds of those who had experienced the trenches. They had seen what happened when infantry units found themselves caught between the explosive reach of hand grenades, effective only to about 30 yards, and the distant thunder of heavy artillery that required complex coordination and couldn't always reach where it was needed most. There was a gap, a deadly void in the infantryman's arsenal, and soldiers had paid for it with their lives. The army needed something portable, something a squad could carry and deploy in minutes, something that could lob explosives over obstacles and into enemy positions that rifles and machine guns couldn't touch. They needed a light mortar, but in 1920, America didn't have one worth deploying. The search for that weapon would lead the US Army on a decade-long journey that would eventually put one of the most effective infantry support weapons of World War II into the hands of American fighting men. This is the story of how the M2 60mm mortar transformed from a French design gathering dust in procurement offices into the commander's hip pocket artillery, the weapon that would save countless American lives from Guadalcanal to the Rhine, from the black sands of Iwo Jima to the frozen hills of Korea. The modern infantry mortar traces its origins to World War I, when British inventor Wilfred Stokes developed his eponymous mortar to address the unique challenges of trench warfare. The Stokes mortar was revolutionary in its simplicity, a smooth bore tube mounted on a base plate with a fixed firing pin at the bottom. Drop a finned bomb down the tube and it would detonate the primer on impact with that firing pin, launching the projectile in a high arc toward enemy trenches. It was crude, it was effective, and it changed infantry tactics forever. Across the lines, French forces faced the same tactical problems as their British allies. Among those grappling with these challenges was Edgar William Brandt, a man whose name would become synonymous with mortar design for generations. Edgar Brandt was born in 1880 in Paris, and his early career had nothing to do with weapons of war. Brandt was an artist, a silversmith and ironworker who crafted elegant metalwork, jewellery and decorative pieces. By 1901, he had established his own workshop in Paris's 16th arrondissement, creating crosses, brooches and commissioned pieces for wealthy clients. His craftsmanship was meticulous, his eye for design impeccable. He seemed destined for a quiet career as a respected artisan in the Art Nouveau movement that was sweeping through France. Then came August 1914 and the guns of August. The Great War swept Edgar Brandt from his workshop into the French army, where his skills as a metalworker would find an unexpected application. Serving in the trenches, Brandt observed firsthand the desperate need for weapons that could attack enemy positions from behind cover. The Stokes mortar had proven the concept, but Brandt's trained eye as a craftsman saw room for improvement, particularly in the projectiles themselves. In 1915, working in military workshops, Brandt designed 2 pneumatic weapons, a 60mm mortar and later a 60mm version mounted on a cast aluminum baseplate. But his real innovation came in the projectile design. Brandt created an aerodynamic teardrop-shaped shell with flat stabilizing fins at the rear, a design that would define mortar ammunition for decades to come. More importantly, he added obturation grooves around the widest part of the shell. These grooves served as both a forward-bearing surface and a gas check, dramatically improving both accuracy and range by creating a better seal in the barrel. The French military initially dismissed Brandt's innovations, but in September 1917, as the war ground through its bloodiest years, the Ministry of Inventions sent out a circular requesting improved projectile designs for the Stokes mortar. Brandt scaled up his 60mm design to 81mm, and both the British and French militaries adopted versions of his ammunition in 1918. The war ended before Brandt's designs could fully prove themselves, but he had planted the seeds of a revolution in infantry fire support. After the war, Brandt didn't return to making jewellery and decorative metalwork. He had found a new calling in weapons design. Throughout the 1920s, Brandt refined his mortar systems, developing improved ammunition with multiple obturation grooves that became the pattern for nearly every mortar shell designed since. In January 1925, he applied for a patent on this design, and the French army adopted his FA Model 1924-27 ammunition. By 1927, Brandt's company had developed the Model 27 mortar, an 80mm weapon that would become one of the most copied and influential designs in military history. The Model 27 was improved again in 1931 to become the Model 2731, and this design would be licensed or copied by Austria, Denmark, Germany, Japan, the Netherlands, Russia, Italy, and crucially for our story, the United States. But before the Americans would adopt Brandt's 81mm mortar, they would purchase something smaller, a 60mm weapon that Brandt had developed in 1935 specifically for company-level infantry support. Meanwhile, in America throughout the 1920s, Army officers and weapons procurement specialists wrestled with the same tactical gap that had plagued them in World War I. During the late 1920s, the War Department launched a formal program to examine light mortars as infantry support weapons. They looked at various domestic designs, considered modifying existing weapons, and evaluated foreign systems. The requirements were clear: the weapon had to be light enough for a 3-man crew to carry and deploy quickly, powerful enough to deliver effective fire support at company level, reliable enough to function in any conditions, and simple enough that soldiers could learn to operate it with minimal training. Multiple designs were tested throughout the early 1930s, but none fully met the Army's requirements. Some were too heavy, others lacked sufficient range, and many suffered reliability problems. Then, in 1938, someone in the Ordnance Department finally paid attention to what Edgar Brandt had been developing in France. The Brandt Model 1935 60mm mortar was exactly what the US Army had been searching for. It was a simple, elegant weapon, consisting of a smoothbore metal tube fixed to a rectangular base plate with a lightweight bipod mount. The firing mechanism was brilliantly straightforward: a fixed firing pin at the base of the tube that would strike a primer in the tail of the mortar bomb when it was dropped down the barrel. The impact would detonate a 20-gauge shotgun shell filled with ballistite powder, launching the bomb in a high arc toward the target. The Brandt design could fire high explosive smoke and illumination, rounds out to nearly 2,000 yards, more than double the range of hand grenades, and with far more destructive power. For a weapon that weighed only 42 pounds when broken down into its 3 components, the tube, baseplate, and bipod, this was remarkable capability. The US Army Ordnance Department purchased 8 Brandt Model 1935 mortars in 1938 and immediately began evaluation tests. The French mortars performed admirably in testing. They were accurate, reliable, and delivered the fire support capability the Army desperately needed. There was only one problem: the French used metric threads, metric measurements, and French manufacturing standards that didn't match American tooling and production methods. If the United States was going to adopt the Brandt mortar, it would need to be Americanized. The Watervliet Arsenal in New York received the task of creating production drawings that would adapt the French design to American standards. Engineers carefully measured every component, converted metric dimensions to imperial measurements, redesigned threaded connections to use American standard threads, modified the base plate to use American steel specifications, and adjusted tolerances to match American manufacturing capabilities. The resulting weapon was functionally identical to the French original, but could be manufactured entirely with American tooling and materials. The modified design was standardized as the Mortar 60mm M1. But before mass production could begin, the Ordnance Department made one final revision, renaming it the Mortar 60mm M2. In January 1940, as war raged across Europe and the fall of France loomed on the horizon, the War Department placed its first production contract for 1,500 M2 mortars with the Red Machinery Company of York, Pennsylvania. The urgency was palpable. German forces had demonstrated devastating effectiveness with their combined arms tactics, and American military planners knew that the United States was woefully unprepared for modern warfare. The M2 mortar would give American infantry companies their own organic fire support, but only if it could be produced in sufficient quantities and if soldiers could be trained to use it effectively. The weapon that emerged from American factories was deceptively simple. The M2 consisted of 3 main components: the tube, a smoothbore steel barrel 28.6 inches long weighing 12.8 pounds, the M5 bipod, a lightweight support structure with elevation and traverse mechanisms weighing 16.4 pounds, and the base plate, a rectangular steel plate weighing 12.8 pounds that absorbed recoil and kept the weapon stable during firing. Total system weight was 42 pounds, light enough that a 3-man crew could carry the weapon and still maintain mobility with their infantry unit. The operational concept was elegant in its simplicity. The crew would set up the baseplate, mount the tube, attach the bipod, and adjust elevation and traverse to aim at the target. A mortar shell would be prepared by attaching the appropriate number of propellant increment charges to the fins, then the gunner would drop the shell down the tube. When the primer in the shell's tail struck the fixed firing pin at the base of the tube, it would detonate, launching the shell in a high parabolic arc. Depending on the number of increments attached and the elevation angle, the M2 could deliver shells anywhere from 100 yards out to a maximum range of 2,000 yards. The high angle of fire meant the shells could clear obstacles like buildings, hills or fortifications and drop nearly vertically onto the target. This made the M2 invaluable for hitting enemies in defilade, those tucked behind cover that direct-fire weapons couldn't reach. The ammunition developed for the M2 was equally well designed. The primary round was the M49A2 high-explosive shell, weighing 2.94 pounds with a bursting charge of 0.34 pounds of TNT. The warhead featured a point-detonating fuse that would explode on impact, showering the target area with deadly fragments. The bursting radius was approximately 17 yards, making it effective against infantry and light fortifications. For marking targets or providing illumination, the M83 illuminating round suspended a parachute flare generating 11,000 candle power, burning for about 25 seconds. This gave commanders the ability to light up the battlefield at night for observation, or to mark targets for other units. The M302 white phosphorus round, introduced late in the war, could generate smoke screens to conceal friendly movements or act as an incendiary weapon against enemy positions. The white phosphorus would ignite spontaneously when exposed to air, creating both a thick smoke cloud and casualties if it struck enemy personnel. For training, the M69 practice round featured a cast-iron body with inert filler, allowing crews to practice without expending expensive live ammunition. A trained M2 mortar crew typically consisted of 3 men, a squad leader who also served as the gunner, an assistant gunner who handled aiming adjustments and maintained the weapon, and an ammunition bearer who prepared rounds and fed them to the gunner. Additional ammunition bearers would often accompany the crew to ensure adequate supplies during extended engagements. In Marine Corps organisations during early World War II, the mortar section was part of the weapons platoon, with 16 Marines manning 3 M2 mortars. This organisational structure changed in May 1944 when the weapons platoon was eliminated, and mortar sections came under direct control of the rifle company commander with 20 Marines manning the weapons. The rate of fire was impressive. A well-trained crew could sustain 18 rounds per minute, and for short durations during desperate defensive situations, crews achieved burst rates of 30 to 35 rounds per minute. Theoretical maximum rate of fire approached 100 rounds per minute, though this was unsustainable and risked damaging the weapon or injuring the crew. As production ramped up in 1940 and 1941, the M2 began reaching training units. This is where the first challenges emerged. The weapon was simple to operate in theory, but effective employment required skills that took time to develop. Crews had to learn how to accurately estimate ranges in varied terrain, calculate the number of propellant increments needed for different distances, adjust fire based on observed impacts, set up and displace the weapon quickly under combat conditions, maintain the weapon in adverse weather, and most critically, coordinate with forward observers and company commanders to provide timely, accurate fire support. Training accidents were mercifully rare, unlike the heavier weapon systems. The M2's relatively low weight and simple operating mechanism made it safer to train with than many contemporary weapons. Soldiers could become proficient in basic operations within a few days, though true mastery of indirect fire techniques took weeks of practice. By late 1941, when the United States entered World War II following Pearl Harbor, several thousand M2 mortars had been produced and distributed to training units, but the weapon remained largely untested in actual combat. The Army and Marine Corps knew the M2 worked on training ranges, but how would it perform when Japanese soldiers were attacking or German artillery was falling? The answers would come soon enough on the steaming jungles of Guadalcanal, the coral atolls of Tarawa, the hedgerows of Normandy, and 1,000 other battlefields where American infantry would desperately need the fire support that the M2 could provide. The initial production contract for 1,500 mortars in January 1940 was just the beginning. As requirements rose throughout 1940 and early 1941, The War Department placed additional contracts with Kennedy Van, Sawn Engineering Company in Danville, Pennsylvania. By the time of Pearl Harbor, production was running at steady pace, but the explosion of demand after America entered the war strained manufacturing capacity. Red Machinery and Kennedy Van Sawn worked around the clock, but it wasn't enough. In 1943, the War Department added Firestone Tire and Rubber Company to the production program, leveraging their manufacturing expertise to increase output. Production fluctuated with military requirements. It declined in early 1944 as stockpiles built up and tactical doctrine shifted, but by the end of 1944, demand surged again as the intensity of combat in both theatres increased. The War Department ordered increased production, and during the first 8 months of 1945 alone, factories produced 30,152 M2 mortars, nearly equaling the total output of the previous 3 years. By war's end, more than 60,000 Ileasti Isuzu mortars had been manufactured, an impressive industrial achievement that ensured American infantry companies would never lack for organic fire support. The first sustained combat test of the M2 mortar came in August 1942 in a place that would become legendary in Marine Corps history, Guadalcanal. The campaign to secure this small island in the Solomon Islands would last 6 brutal months, and the M2 mortar would prove itself as an indispensable weapon in jungle warfare. The tactical situation on Guadalcanal was unique and challenging. Dense jungle vegetation limited visibility and fields of fire. The oppressive heat and humidity caused weapons to malfunction. Torrential rains turned the ground to mud. Resupply was uncertain and ammunition had to be conserved, and Japanese forces attacked with ferocious determination, often at night when American advantages in firepower were diminished. In this environment, the M2 mortar demonstrated capabilities that made it invaluable. Its high-angle fire could reach Japanese positions hidden in the jungle, where direct-fire weapons were ineffective. The weapon was light enough to be manhandled through the jungle and set up quickly when contact was made. Crews could lay down sustained fire to break up Japanese attacks or support Marine advances. The illumination rounds allowed Marines to see and engage Japanese infiltrators during terrifying night attacks. Marine Corps mortar sections, initially part of weapons platoons, learned through hard experience how to employ the M2 effectively in jungle conditions. Setting up in covered positions, they could remain relatively protected while delivering fires anywhere within a 2,000-yard radius. Forward observers with rifle companies would call for fire missions, and within minutes, M2 shells would begin falling on Japanese positions. The psychological impact on Japanese forces was significant. The unexpected arrival of mortar fire disrupted attacks and sapped morale. One of the most famous actions involving the M2 occurred during the Battle of Henderson Field in late October 1942. Japanese forces launched a massive assault against Marine positions defending the critical airfield. Among the defenders was Gunnery Sergeant John Basilone, commanding machine gun sections, but his position was supported by mortar crews who worked through the night firing illumination rounds to reveal Japanese attackers and high explosive shells to break up their formations. The M2 crews fired until their tubes glowed hot, dropping rounds down the barrels in rapid succession as ammunition bearers struggled to keep them supplied. The combination of machine gun fire and mortar barrages helped turn back wave after wave of Japanese attacks. Basilone would receive the Medal of Honor for his actions that night, but the mortar crews who supported him deserve equal recognition for keeping American positions from being overwhelmed. As the Guadalcanal campaign ground on through late 1942 and into early 1943, Marine and Army mortar crews refined their tactics and developed new techniques for employing the M2 in jungle warfare. They learned to pre-register defensive fires, marking coordinates around their positions so they could quickly engage attackers even in darkness or poor visibility. They developed procedures for rapidly shifting fires between targets as the tactical situation changed. They mastered the art of walking fire across suspected enemy assembly areas to disrupt attacks before they could develop. Perhaps most importantly, they learned that the M2 was only as effective as the ammunition supply. Crews that ran out of shells became liabilities, unable to support their infantry comrades when it mattered most. This led to changes in how ammunition was stockpiled and distributed, ensuring that mortar crews always had adequate supplies. The next major test came in November 1943 at Tarawa, a tiny coral atoll in the Gilbert Islands that the Japanese had turned into a fortress. The Battle of Tarawa would be one of the bloodiest in the Pacific, and the M2 mortar would play a crucial role in reducing Japanese fortifications. The tactical situation at Tarawa was dramatically different from Guadalcanal. No jungle, no concealment, just flat coral with Japanese bunkers and pillboxes dominating every approach. The M2 crews had to set up in the open, often under direct fire, and deliver precision fires against hardened targets. The high-angle fire of the M2 proved essential for attacking Japanese positions that were immune to direct fire. Mortar shells could drop through the firing slits of bunkers or explode on top of fortifications, killing or stunning the defenders inside. Mortar crews worked in coordination with engineers and infantry assault teams, suppressing Japanese positions with high explosive fire while demolition charges were placed. The white phosphorus rounds, now available in larger quantities, were used to mark targets for naval gunfire or to create smoke screens that allowed Marines to maneuver across exposed ground. The three-day battle for Tarawa was a bloodbath, but Marine Corps after-action reports consistently praised the effectiveness of the 60mm mortar in the assault. Unit commanders requested more mortars and more ammunition, recognizing that this weapon gave rifle companies a decisive advantage in reducing fortified positions. As American forces pushed across the Pacific through 1944, the M2 mortar went with them to Kwajalein, Saipan, Guam, Peleliu, and dozens of other islands. Each campaign added to the body of knowledge about how to employ the weapon effectively. In the European theatre, the M2 saw its first major action during the invasion of Normandy in June 1944. American airborne units parachuting into France on the night of June 5th carried M2 mortars broken down into their components, with crews jumping separately from their weapons, which arrived in equipment bundles. Once on the ground, paratroopers reassembled their mortars and immediately put them into action against German positions. The M2 proved equally effective in European combat as it had in the Pacific. In the hedgerow country of Normandy, where every field was surrounded by thick earthen banks topped with vegetation, the high-angle fire of the mortar could reach German positions that were invisible to direct-fire weapons. In urban combat, mortar crews could set up behind buildings and deliver fires onto German positions several streets away. During the race across France in late summer 1944, the M2's light weight allowed mortar crews to keep pace with rapidly advancing infantry, providing immediate fire support whenever resistance was encountered. The Battle of the Bulge in December 1944 demonstrated the M2's value in defensive operations. American units, many caught by surprise by the German offensive, found themselves surrounded or fighting desperate delaying actions. Mortar crews firing from hastily prepared positions helped slow German advances and break up attacks, buying time for reinforcements to arrive. In the frozen Ardennes forests, crews faced new challenges. The cold caused weapons to become brittle and prone to cracking, ammunition propellant burned less efficiently in extreme cold, reducing range, snow and ice made it difficult to achieve stable bipod and baseplate placement, and frozen ground absorbed less of the baseplate recoil, causing mortars to shift position with each shot. American ingenuity found solutions. Crews learned to warm ammunition before firing, dig through snow to reach more solid footing for baseplates, use wooden blocks under baseplates to improve stability, and fire shorter preparatory missions to ensure the weapon was zeroed before engaging time-sensitive targets. By early 1945, as American forces pushed into Germany itself, the M2 mortar had become an integral part of every rifle company's capabilities. Infantry commanders had come to rely on their mortar sections as hip-pocket artillery, responsive fire support that was immediately available without having to coordinate with distant artillery units. But the ultimate test of the M2's worth was yet to come on an 8-square-mile volcanic rock called Iwo Jima. The invasion of Iwo Jima on February 19, 1945, would see some of the most intense combat of the entire war, and the M2 mortar would be there from the first moments. Marine divisions hitting the beaches carried their mortars ashore in the initial assault waves. This was a calculated risk. Mortars were valuable assets that could be lost if landing craft was sunk or if crews were killed before they could deploy the weapons. But commanders knew that Japanese defences on Iwo Jima were the most sophisticated they had yet encountered, and they would need every weapon available from the moment boots hit the black volcanic sand. The Japanese commander, General Tadamichi Kuribayashi, had prepared defences that exploited Iwo Jima's terrain perfectly. Miles of tunnels connected hundreds of fortified positions. Artillery and mortar positions were cunningly camouflaged. The volcanic rock absorbed explosions without yielding. Every square yard of the island was pre-registered for Japanese fires, and defenders were ordered to fight to the death rather than conduct suicidal banzai charges. Into this hellscape came 70,000 Marines, supported by massive naval and air bombardment. Among their weapons were the M2 mortars that had proven themselves from Guadalcanal to Tarawa to Saipan. The black volcanic sand of Iwo Jima presented immediate challenges for mortar crews. The loose sand made it nearly impossible to achieve stable baseplate placement. Mortars would shift with each shot, throwing off accuracy and requiring constant re-aiming. The sand absorbed the recoil differently than normal soil, and crews had to develop new techniques for keeping their weapons steady. Japanese mortar and artillery fire was the most intense Marines had yet experienced. Crews setting up their mortars found themselves under immediate counterfire. Casualties among mortar sections were heavy in the first days of the battle, but the M2 proved its worth again and again. As Marines fought toward Mount Suribachi in the southern part of the island, mortar crews provided suppressing fire against Japanese positions. The high-angle fire could reach into ravines and onto reverse slopes where Japanese defenders sheltered. When Marines finally reached the summit of Suribachi on February 23rd and raised the American flag in that iconic moment, they had been supported every yard of the way by M2 mortar fire. The battle for the northern part of Iwo Jima, with its complex of ridges, hills and fortified positions that Marines called the meat grinder, would drag on for another month. Mortar crews fought day and night, firing thousands of rounds to support the agonizingly slow advance. They were so close to the fighting that they often came under direct fire. The distinction between mortar crews and infantry blurred as everyone fought to survive. On February 19th, the first day of the invasion, Gunnery Sergeant John Basilone, the Medal of Honor recipient from Guadalcanal, came ashore with his machine gun section. Mortar crews nearby watched as Basilone led his men inland under intense fire. He personally knocked out a Japanese blockhouse and guided a tank through a minefield. Then, moving around the edge of Airfield No. 1, a Japanese mortar round struck near him, killing Basilone instantly. He would be posthumously awarded the Navy Cross, the only Marine in World War II to receive both the Medal of Honor and the Navy Cross. The irony was bitter. A man who had survived some of the war's most intense combat, who had been supported by mortars at Henderson Field, was killed by a mortar on Iwo Jima. The 36 days of fighting on Iwo Jima cost nearly 7,000 American lives, with another 20,000 wounded. But the island was secured, and B-29 bombers would use it as an emergency landing field, saving the lives of thousands of airmen who would have otherwise crashed into the Pacific. M2 mortar crews fired tens of thousands of rounds during the battle, wearing out tubes and depleting ammunition stocks. The weapon had proven that even against the most determined and sophisticated defences the Japanese could create, American infantry with their M2 mortars could prevail. In the Korean War beginning in 1950, the M2 mortar saw extensive service again. The weapon that had fought through Pacific jungles and European hedgerows now found itself in Korean hills and valleys. The war's back-and-forth nature, with massive offensives followed by grinding defensive battles, showcased the M2's versatility. During the desperate fighting of the Busan perimeter in summer 1950, M2 crews provided critical fire support as outnumbered American and South Korean forces held off North Korean attacks. As United Nations forces drove north in fall 1950, mortars provided mobile fire support for the rapid advance. When Chinese forces intervened and pushed UN forces back, mortars helped cover the retreat and then formed part of the defensive fires as new lines were established. In the static warfare that characterized the latter part of the Korean War, mortar crews fired from prepared positions, engaging Chinese and North Korean forces across no man's land in exchanges reminiscent of World War I. The M2 continued proving its worth through Korea and would soldier on into Vietnam, finally being replaced by the M224 mortar in 1978. Edgar Brandt's basic design, Americanized and manufactured by the tens of thousands, had served American forces for nearly 4 decades. The numbers tell part of the story. 60,000 M2 mortars produced during World War II, millions of rounds of ammunition expended, countless enemy positions destroyed, uncounted American lives saved by timely fire support. But numbers alone cannot convey what the M2 mortar meant to the infantrymen who depended on it. To a Marine pinned down on Tarawa's coral, the distinctive thump of M2 mortars firing behind him and the sight of shells dropping onto Japanese positions gave hope. To a soldier in the Ardennes holding against a German attack, the whistling arrival of mortar rounds breaking up enemy formations meant survival. To a squad leader trying to reduce a bunker or pillbox, the ability to call for mortar fire that would suppress the position while his men manoeuvred was the difference between success and failure. The M2 earned its nickname as the commander's hip-pocket artillery because it was always there, immediately available, responsive to the needs of the infantry it supported. Battalion and regimental commanders had their organic artillery, but rifle company commanders had their mortars, and that made all the difference at the critical point of combat. The weapon's success stemmed from several key factors. Simplicity. The M2 had no complex mechanisms to break or malfunction. Reliability. It worked in jungles, deserts, Arctic cold, and everything in between. Versatility, high explosive smoke, and illumination rounds gave commanders tactical flexibility. Portability. A 3-man crew could manhandle the weapon anywhere infantry could go. Immediate responsiveness. Fire support was seconds away, not minutes, and adequate range and lethality. 2,000 yards and a 17-yard burst radius gave it tactical utility against most targets. The M2 also benefited from excellent training, strong logistic support, and sound tactical doctrine. The US military recognized the weapon's value and invested in ensuring crews were properly trained and adequately supplied. Compare this to many adversaries who failed to develop equivalent capabilities or who misemployed the weapons they had. The combination of good equipment, good training, and good employment created a weapon system that multiplied American infantry effectiveness. The legacy of the M2 mortar extends far beyond its years of direct service. The weapon demonstrated that company-level organic fire support was not just desirable, but essential. Every modern infantry company has some form of light mortar because the M2 proved the concept's value. The tactics developed for employing the M2, forward observer coordination, pre-registered defensive fires, rapid displacement, integration with maneuver elements remain relevant today. The ammunition types, high explosive, illumination, and smoke, are still the standard types for light mortars. Even the basic design, a smoothbore tube with baseplate and bipod, remains the pattern for modern systems. The M224 mortar that replaced the M2 in 1978 is heavier and more capable, but it follows the same operational principles that Edgar Brandt established and that the M2 perfected through decades of combat service. In 1985, at a reunion in Arizona, American and foreign veterans who had faced each other in combat gathered in peace. Among them were men who had operated M2 mortars and men who had been on the receiving end of American mortar. Fire. The conversations were revealing. Japanese veterans spoke of dreading the arrival of American mortar fire, how it seemed to come from nowhere and fall with terrifying accuracy. They described the psychological impact of hearing the distinctive thump of mortars firing, knowing that within seconds death would rain down. German veterans acknowledged grudging respect for American fire support capabilities. One former Wehrmacht officer noted that American infantry companies had fire support immediately available, that German companies had to request from higher headquarters, and that American mortar crews seemed to have unlimited ammunition compared to German forces struggling with shortages. Chinese and North Korean veterans from Korea told similar stories about American mortar effectiveness. The weapons were always there, always firing, always accurate. They represented American industrial might and the superior training that produced crews who could employ their weapons with devastating effect. For the American veterans, the memories were different but equally powerful. They remembered mortar crews as the unsung heroes who saved their lives countless times, the thump of friendly mortars firing as the most welcome sound in combat, the teamwork between infantry and mortar crews that became second nature, the absolute confidence that fire support would be there when needed, and the gratitude owed to crews who exposed themselves to danger to provide that support. These testimonies reveal the true measure of the M2 mortar's success. It was not about technical specifications or production numbers. It was about American infantry knowing that they had responsive, reliable fire support that gave them an edge in combat. The M2 mortar story is fundamentally about people. Edgar Brandt, the French artist turned weapons designer whose innovations created the pattern for modern mortars, American engineers at Watervliet Arsenal who adapted a foreign design to American manufacturing methods, workers at Red Machinery, Kennedy Van Sown, and Firestone, who built tens of thousands of weapons under wartime pressure, soldiers and marines who trained with the weapon and perfected its employment, mortar crews who carried the weapon into combat and fired it under the most desperate circumstances, infantry commanders who learned to integrate mortar fire into their tactical plans, and the thousands of American fighting men whose lives were saved by timely, accurate mortar support. The development of the M2 also illustrates important lessons about military procurement and weapons development. The Army spent a decade searching for the right light mortar, testing multiple designs before finally recognizing that a proven foreign system met their needs. There was no pride or not invented here syndrome preventing adoption of Brandt's design. When evaluation showed the French mortar was superior to anything America had developed, the Army pragmatically licensed the design. This intellectual honesty and willingness to adopt foreign innovations when they were superior to domestic alternatives served America well. The adaptation process demonstrated engineering competence as well. Simply copying the French design would have created manufacturing and logistics problems. By carefully converting the design to American standards while preserving its operational characteristics, Waterfly Arsenal created a weapon that could be efficiently mass-produced and maintained. The production program showed American industrial capability at its finest. 3 companies with different core competencies, specialized machinery, engineering, and rubber manufacturing, all successfully produced a complex weapons system to exacting military specifications. When demand surged in late 1944 and early 1945, production increased dramatically. The 30,152 mortars produced in the first 8 months of 1945 equaled output from 3 previous years, demonstrating the kind of industrial flexibility that helped America win World War II. The M2 mortar might seem like a minor weapon compared to the tanks, aircraft, and warships that dominate popular imagination of World War II. There are no dramatic stories of a single mortar changing the course of a battle, no ace mortar crews with dozens of kills, no famous quotes about mortar supremacy. But in the unglamorous reality of infantry combat, where victories are measured in yards gained and casualties inflicted, the M2 mortar was absolutely critical. Every rifle company that went into combat had mortar support. Every attack, every defense, every firefight involved mortars providing fires. Day after day, battle after battle, campaign after campaign, the M2 was there doing its job. This reliability, this consistency, this constant presence made the M2 one of the unsung heroes of American military success in World War II and Korea. The weapon gave American infantry a capability that many adversaries lacked or couldn't match. It represented a tactical advantage that multiplied the effectiveness of soldiers and marines across the globe. In the final analysis, the M2 60mm mortar succeeded because it perfectly filled the niche it was designed for, bridging the gap between hand grenades and artillery with a weapon that was light, reliable, and immediately responsive to infantry needs. From its origins in Edgar Brandt's World War I innovations through its adoption by the US Army in 1940 and its combat service from Guadalcanal to Korea, the M2 proved itself again and again. Today, original M2 mortars are museum pieces, historical artifacts that testify to a bygone era of warfare. But their legacy lives on in every modern light mortar that provides company-level fire support. The lessons learned in employing the M2 inform current tactics. The organizational structure that proved effective, mortar sections directly supporting rifle companies, remain standard. The ammunition types perfected for the M2 continue, in modern variants. In 1920, American officers stood in that Pennsylvania field, knowing they needed something better for their infantry. In 1938, they found it in Edgar Brandt's French design. In 1940, they Americanized it and began production. From 1942 to 1953, they proved it in combat across 2 world wars and multiple theatres. The M2 60mm mortar became the infantry's secret weapon, not because it was secret, but because it was so ubiquitous, so reliable, so effective that it became invisible, just another tool that American infantry could depend on absolutely. That, in the end, is the highest praise any weapon can receive. It worked when it was needed, every time, everywhere, without fail. The young Marines struggling up Mount Suribachi, the paratroopers defending Bastogne, the soldiers holding Pusan perimeter, all had one thing in common. When they needed fire support immediately, their M2 mortar crews were there, dropping rounds down the tube and providing the covering fire that helped them survive and prevail. That is the story of how the M2 mortar became the infantry's secret weapon. Not through revolutionary technology or dramatic innovation, but through sound design, solid engineering, effective production, thorough training, and thousands of anonymous crews who did their job under fire. Edgar Brandt would have been proud. The US Army got what it needed, American infantry received a weapon they could trust, and the M2 60mm mortar earned its place in history as one of the most successful and longest-serving infantry support weapons ever fielded.